Okay, student, good morning. So we are doing the discrete time Markov chain. So today we are going to start the limiting probability. So let me start with that. Okay, so we are going to start the limiting probabilities. That means the long run behavior of Markov chains. So let us say that our state space is finite. Okay, so then we say that TPM is regular. So P is the TPM. So given TPMP is regular, if PK has all its element positive, such TPM and is called regular, and corresponding Markov chain is also said to be regular. Or corresponding Markov chain is called regular Markov chain. The most important fact concerning the regular Markov chain is the existence of limiting probability. Okay. So the most important fact concerning a regular Markov chain is the existence of a limiting probability distribution pi, which is pi naught so on to pi n, where pi j for all j and mute yourself na. So the most important fact concerning the regular Markov chain is the existence of limiting probability pi such that summation pi j is equal to 1, and this distribution is independent of initial state. Okay, so formally for a regular TPM, if we have a regular TPM, let us say P, whose elements are, let us say Pij. Okay. So okay, so we have convergence limit n goes to infinity Pij n is equal to pi j for all j which is 0, 1, 2, n. That means what is the meaning of this? Meaning is that limit as n goes to infinity, probability xn is equal to j given x naught is equal to I is pi j for all j. So this convergence means that in long run the probability of finding the Markov chain in state j is pi j, approximately pi j, no matter in which state the chain Markov chain begin at time 0. So we are saying that the Markov chain is, let us say, is regular, then in long run, that means when n goes to infinity, then probability of finding Markov chain in state j is pi j, no matter where the chain starts. Okay, let us take an example. Consider a TPM where some signals are transmitted such that signal is transmitted as 0, it is received as 0 with probability, let us say 1 minus a, it is transmitted as 0, received as 1 with probability a, transmitted as 1, received as 0, probability is b, and similarly it is transmitted as and received as 1 is 1 minus b. Okay, so such that a and b between 0 to 1. Here further we assume that mod of 1 minus a minus b is less than 1. So for the case where a is equal to b is equal to 0 or a is equal to b is equal to 1, this case we see separately. Okay, so this case we will not take, other cases we are taking. So that means your, if this is the case, a and b are not 0 and 1, if they are not 0 and 1, then in general case, then whether p is regular or not. all the elements are positive here. No need to see other things because p raised to power k has all its element positive greater than 0. So here the TPM is regular because a and b 0 we are not taking. So p is regular TPM here because in the first case p raised to power 1 itself is positive. So okay, so let us say we want to determine what is p raised to power n. Okay, so let us determine that. So here p00 is 1 minus a, p01 is a, p10 is b, p11 is 1 minus b. So also your p00 n, okay, p00 n. So using Chapman-Kolmogorov equation, this will be p00 n minus 1 p00 plus p01 n minus 1 p10. Okay, is it okay using Chapman-Kolmogorov equations? Am I audible to you?
Yes, sir. Yes, sir.
Okay, okay. So using CK equations, this can be written as p00 n minus 1 p00 plus p01 n minus 1 p10. So p00 is 1 minus a here and p00 n minus 1 plus p10 is b and also p01 because only two states are there, 0 and 1 are there. So clearly p01 n minus 1 will be same as that of 1 minus p00 n minus 1 because only two states are there. So therefore this will be 1 minus p00 n minus 1. But therefore this value is b plus 1 minus a and this value minus b p00 n minus 1 when n is greater than 1. Now this is p00 n. Now similarly expanding this in the same fashion, this will be b plus again p00 n minus 1. Again you plug in this value recursively. So you will get b plus 1 minus a minus b p00 raised to n minus 2. So you will get b 1 minus, okay, so that will be b and we will have again 1 minus a minus b into b plus 1 minus a minus b p00 n minus 2. So we will have b plus b 1 minus a minus b plus 1 minus a minus b square p00 n minus 2 and so on. This will be b plus b 1 minus a minus b plus b 1 minus a minus b square plus so on plus b 1 minus a minus b raised to power n minus 2 plus p00. In the last we will have p00 1 minus a minus b raised to power n minus 1, but P00 is 1 minus a. Okay, so therefore this value will be B summation k is from 0 to n minus 2, 1 minus a minus b raised to power k plus 1 minus a, 1 minus a minus b raised to power n minus 1. Now this summation, okay, this summation will be 1 minus a minus b raised to power n minus 1 upon 1 minus a minus b. So therefore in the denominator we will have a plus b basically. This value is this. Okay, so now solving this, we will have b divided by a plus b plus a 1 minus a minus b raised to power n upon a plus b, because here solving this we are getting a plus b. You multiply, taking the denominator and just adjust the values, so you will have a upon 1 minus a minus b raised to power n here. So this is the value of P00n. In the same fashion, you find out other values also. So therefore, similarly, we will find out P raised to power n, which is B plus a 1 minus a minus b raised to power n upon a plus b, a minus a 1 minus a minus b raised to power n upon a plus b, b minus b 1 minus a minus b raised to power n upon a plus b, a plus b 1 minus a minus b raised to power n upon a plus b. This is p raised to power n 0 1 0 1 here. Okay, so therefore we are getting this value. Now you take note that one minus a minus b is less than 1 and a comma b is between 0 to 1. So therefore 1 minus a minus b raised to power n goes to 0 as n goes to infinity. So therefore take limit as n goes to infinity, p raised to power n. This becomes b upon a plus b, a upon a plus b from here, b upon a plus b and a upon a plus b. So this is the answer we are getting here. So that means limit as n goes to infinity, Pn basically going to this value. Now we may assume that signals are basically transmitted. Okay, if it is transmitted 0, it will be received as 0. So in long run, it will be received as 0 if this TPM is there, b upon a plus b. If it is transmitted as 0, received as 1 with the probability a upon a plus b. It is transmitted as 1, received as 0 with the probability b upon a plus b. It is transmitted as 1, received as 1 with the probability a upon a plus b if the TPM is regular and corresponding Markov chain is correspondingly a Markov chain is there. Okay, so now Let us take the initial state. Okay, so let us take initial state as, let us say, probability. Let x naught is equal to, so it doesn't matter basically which initial state you start. Let us say 1 by 3 and probability x naught is equal to 1 as 2 by 3. Okay, that means initial state probability mass function, probability distribution is P naught, which is 1 by 3, comma 2 by 3. So what will be the value of Pn? Yes, can anyone tell what is the value of the xn step? If you remember the formula. For the initial step x naught, value is probability mass function is this. So what is the, for step xn, what is the probability mass function?
P of n minus 1 into TPM.
Yes. So you can recursively just put that as P raised to power n minus 2 into P square, where P is the TPM. And in the last, you will get P0 into P raised to power n. Because this formula is same. This is n minus 1 into Pn, which can be recursively solved as P0. Sorry, this is P. P recursively solved as Pn. This is the same thing. So that means this is 1 by 3, comma 2 by 3 into this value, B upon A plus B. Okay, B upon A plus B. This Pn value. Okay, Pn is this star value. Okay, take Pn from star. Okay, now what you will get? As n goes to infinity, limit as n goes to infinity, Pn. So you can easily see that 1 by 3 will be multiplied with first, 2 by 3 will multiply with second, and as n goes to infinity, the other value will go to 0. So this will be B upon A plus B. And second one will be A upon A plus B, because 1 minus A minus B raised to power n will go to 0. Similarly, B into 1 minus A upon B, 1 minus A minus B raised to power n also go to 0 as n goes to infinity. So this will be A upon A plus B. Let us say we start with some other initial state. Instead of 1 by 3, comma 2 by 3, I will start with half, comma half. So whether this limiting value will change, If I will start with half comma half, just you see the multiply here and multiply half here. This value plus this value multiply with half. So that will also remain b upon a plus b. That doesn't change. Is it okay now?
Yes, sir.
Okay, I think it is okay now?
Yes, sir.
Okay. So that means this initial state here, if we have a regular TPM, then the same thing we are telling, that this convergence means that in long run, the probability of finding Markov chain in state J is pi j, no matter in which state the chain begins at time 0. So here we have shown this thing at no matter if I start with half also in the initial state, then also this limiting probability will remain the same. Okay, so this was the limiting behavior for regular TPM. Also, you can note down here that this TPM is also 0, 1, from 0 to 0, 1 minus a, and this is 1 minus b, 0 to 1 a, 1 to 0 b. So this is irreducible aperiodic, period is 1 for each state, and all states are positive recurrent. Markov chain. Okay, so this so if your regular Markov chain is your also this is finite because it is finite state. So I can say because it is finite state also, no? Because if it is finite state, then it will automatically and irreducible also. Then that will imply finite state irreducible will automatically imply that it is positive recurrent. So we can also show that finite state aperiodic irreducible Markov chain is regular and recurrent. Okay, that also you can show. So that is also important that you can just check that thing also to show whether the Markov chain is regular or not. So here we note down that finite state aperiodic irreducible Markov chain is regular and recurrent. So this thing also we note down from here. Okay, now to show that if TPM P of n states is regular, then p raised to power n square will have no zero elements. Equivalently, if p raised to power n square is not strictly positive, then Markov chain is not regular. So, for example, we take, let us say, half, half, 0, half, 0, half, half, 0, half. Okay, so this is the, let us say, TPM. So whether it is regular, so either you can check this thing, finite state, a periodic irreducible Markov chain. So other thing is you can just check the sign also. So because it is 3 states, so p raised to power 9 you have to go. Okay, so but we don't have to go that much also. If it is regular also, so that sometimes, so we can just see the sign, plus 0 plus 0 plus 0 plus. So this is p, we can multiply with p. Okay, so what we will get, this is p, we will get p square. So this will be multiplication of this, plus 0 into plus 0, so that will be plus. Next one will be plus into 0, 0 into 0, so that will be plus. Then next will be plus into 0, plus into plus will be plus. The next will be in the same fashion, the next value is plus, next value is also plus, next value is also plus. Similarly, plus, next value is also plus, next value is also plus. So we can see here that in the second case, p square itself is coming out to be all the elements are positive. So therefore, this p is regular TPM, or Markov chain is regular here. Okay, so sometimes we have to go some other. So you may say some other cases also where you may have to check up to p raised to power n also, p raised to power n square also. Okay, let us see a theorem. Let p be a regular TPM on states 0, 1 to n, then the limiting distribution pi, which is pi naught, pi 1, pi n, is the unique non-negative solution of equations pi j is summation k is from 0 to n, pi k pkj, j is from 0, 1 to n, and summation k is from 0 to n, pi k is equal to 1. That means this, if we write in matrix form, pi, so this equations means that pi is equal to pi p and summation pi I, k is from 0 to n, is 1. That is, this is the same thing basically in matrix form. Okay, so this is the same thing. Okay, both are same basically. Both of them are same. So now where pkj is the Cartesian probability. Now we want to show this. So because Markov chain is regular, so we have limiting probability. So that means limit as n goes to infinity, Pijn is equal to pi j, for which summation pi k is from 0 to n is 1, where we are assuming that states are basically 0, 1, 2, n. Okay, these are the state space. Now we know that Pn is Pn minus 1 into P. Okay, just simple multiplication of matrix multiplication. So therefore, from there, what is the ijth element? Pijn is summation k is from 0 to n, or you can write down using the Chapman-Kolmogorov equations also. That is the same thing. Chapman-Kolmogorov equations, you can write down same thing. Pkj, j is from 0 to n. Either you write down the same thing using the Chapman-Kolmogorov, or you just see from here itself. Both of them give the same solution. Okay. Now, because it is limiting probability is existing, because we have seen here that this limiting probability is basically approach towards this value, okay, which is same as that of this value. Okay, so therefore we have, as n goes to infinity, Pijn will converge towards pi j, and Pik n minus 1 also, when n goes to infinity, this will converge towards pi k. It becomes the independent of the initial state. I state, it becomes independent. That also we have seen that it doesn't depend initially where you are starting with. Okay, that doesn't matter. So therefore, applying as n goes to infinity, therefore we will get from here, as n goes to infinity, we will have pi j is summation k is from 0 to n pi k pkj. Okay, this is the same thing, same equation. Pi j is equal to summation pi k pkj. Now this is as claimed. Now to show this solution is unique, suppose that x naught, x1, xn solves xj, which is summation xk pkj, k is from 0 to n, for j which is 0, 1 to n, and summation xk, k is from 0 to n is 1. So we wish to show xj is equal to pi j. We are saying that some x is there which is also solving this kind of equation. We want to show that xj is equal to pi j. Now multiplying here xj, multiply here with pjl and take summation. J is from 0 to n, which will be summation. J is from 0 to n, summation k is from 0 to n, xk p kj pjl. Now this will be summation xk, k is from 0 to n, summation j is from 0 to n, p kj pjl. Now using Chapman-Kolmogorov equation, this is nothing but pkl2. Okay, pkl2. Now using this one, this value is xl, this value is xl, which is equal to summation k is from 0 to n, xk pkl2. Repeating the same argument, what we will get? We will get xl is equal to summation k is from 0 to n, xk pkl, n l is from 0 1 to n. Now as n goes to infinity, pkl n approaches towards pi l, because that we have already shown that because it is a regular TPM, the pkln approach towards pi l becomes independent of the initial state. So therefore, as n goes to infinity, xl is summation k is from 0 to n, xk pi l. Now, but this is basically summation k is from 0 to n xl, pi l will be outside. But that summation is already we have is 1. So that is 1, that is equal to pi l. L is equal to 0, 1 to n. So we have shown that xl is equal to pi l. So therefore, xl is equal to pi l as claimed. So that means we have shown that if P is a regular TPM, then limiting probability is a unique solution of pi is equal to pi p, where summation pi k is equal to 1. So that is the basically solution here. Okay. So any question here till now? Okay. So am I audible to you?
Yes, sir.
Yes, sir.
Okay. Okay. So let us take an example. Let us take an example from assignment Gambler's Ruin problem. So n no claim discount NCD system has the discount classes E naught, no discount, even 20% discount, and E2 40% discount. Movement in the system is determined by the rule whereby one step back, one discount level, or stays in E naught with one claim in a year and returns to a level of no discount if more than one claim is made. A claim-free year results in a step up to a higher discount level or one remains in class E2 if already there. So NCD system is, so we have NCD class E naught, E1, E2, percentage discount 0%, 20%, 40%. So annual premium ₹100. If no discount is there, then ₹100 the person has to pay. ₹80, ₹60. Okay, so we have this. This is the examples of your Gamblers this limiting probability Markov chain basically. And no claim discount system has discount level, no discount, 20% discount, 40% discount, even E naught, even E2. Movement in the system is determined by a rule where one step back, one discount level with one claim a year. So if one claim is there, because if someone does, let us say, some insurance for, let us say, his car or car, etc. Okay, so then if one claim he made in a year, okay, then he is saying that one step back from the discount level. So that means if he is paying 80 rupees, next time he has to pay 100 rupees with one claim in a year, and return to the level of no discount if more than one claim is made. And if, let us say, he is in E2 class, that is 40% discount, he is paying 60 rupees, but he make, let us say, two claims in a year or three claims in a year, then he has to go to level E0. That means 0%. He has to pay annual premium of 100 rupees from the next time. Okay. So a claim-free year result in a step up. So if no claim is made, then if he, let us say, he is in E2, then he will go to E1. If he is in E1, then he will go to E0. And, oh sorry, if he is in E1, then no claim here, then he will go to E2 because more discount is there. If he is in E0, then he will go to E1. Okay. And if it is in E2, then he will remain there. Okay. So now this is the system. If we suppose that for anyone in this scheme, the probabilities of one claim in a year is 0.2, while the probability of two or more claims is 0.1. Find the TPM of the system. So now let us say he is in E0 level, E1 level, E2 level. Now if he is in 0% discount, okay, so he will remain there if one claim or two claims are there. So 0.3, and he will move to one step up with probability 0.7, and he cannot move to E2 level because no claim, he will move one step up only. Similarly, if he is in E1 level, then if one claim is there or two claims are there, then totally 0.3, and no claim 0.7, 0 will be here. If it is in 2, that means E2 level 40% discount, then if he make the one claim, that means 0.2, then he will go to E1 level, and if he make more than two or more claim, then he will go to E0 level 0.1, and 0.7 he will remain here. So this is the TPM. Is it okay? Yes, is it okay or not? because if he is in E0 level, E0 means 0% discount. So then if he make one or more than one claim, then that means with probability 0.3, he will remain there. He can move up according to the question with probability more discount level with probability 0.7 with no claim. Okay, because one step he can move up, other is 0. So this was the first part. Okay. So next time we will do this example, complete this example. We have to find long run probabilities also. In long run, what proportion of time is the process in each of the 3 discount level? So in long run, what is the probability that we will be in E0, E1 or E2? So that we will find next time. Okay, let us stop here. So next time we will continue here. So any question till now?